Okay, well done. So those are the basic principles of Surds, essentially the laws that you've got and how you can apply those laws to simplify different Surds down. What we're going to move on to now is operations with Surds. And what I mean by that is adding and subtracting, maybe expanding some brackets as well. So let's have a look at the first one that we've got here. Now, it's important to note that the only two laws of Surds were to do with multiplication and division. Adding and subtracting, similar to laws of indices from a previous lesson, you need to think about it as collecting like terms. So what I mean by that is, what we have on this first question is 5 root 3 plus 4 root 3 minus a root 3. There's no multiplying, no dividing. Collecting like terms is what it is. One way to think about it is exactly how you collect like terms with algebraic terms. So imagine you had something like 5x's, and then you added on 4 more x's, and then you took an x away. Of course, you get 9x minus 1x, which would give you 8x in total. Very similar with what we have here. I've got 5 root 3's. I want you to listen very carefully to how I say this. It's the way that you should think it through. I've got 5 root 3's. I add 4 more root 3's on, but then I take a root 3 away. If you've got 5 of them and you add 4 on, you've got 9, but then you take one off, you're on 8 root 3's. Second question, again, we're not multiplying or dividing here, we're adding, but we notice they're not actually like terms. I'm not just adding root 8's together or root 50's, I'm actually adding a root 8 and a root 50. So you might be thinking, well, they're not like terms, how can I do it? Well, what we can do is use our simplifying skills from before to make them like terms. Let's have a look at how that would work. The root 8, first of all, square number that goes into it is, of course, 4. We'd need to times that by 2 to give us 8. Similar with the root 50. 25 is the biggest square number that goes into it. Need to times it by 2 to give us the 50. Simplify from there. Root 4 times by root 2 when we split it into 2 separate surds. And then we're going to add on root 25 times root 2. We've got square numbers, we can square root them. That's what we wanted. Root 4 is 2, timesing that by a root 2. Root 25 is 5, timesing that by a root 2. Now what you notice is that you do have like terms, so you can collect them together. Going to say it in a very similar way to how I said the previous one. We've got 2 root 2's, and we're going to add 5 more root 2's onto that. Of course, we've got 7 root 2's altogether then. Exactly the same on the last one, but this time we're subtracting. Again, they're not like terms, so we start by trying to simplify them down. So start with the root 75. 25 is a square number that goes into it, and we need to times that by 3. You'll notice as we move through this, I'm going to assume that you're building in confidence. I might even skip maybe one step of working just to save a bit of time. That's what I've done here. And then what we're going to do here is minus 2 times by, biggest square number that goes into 12 is 4. Need to times that by a 3. Simplify from here. So we've got this root 25, which is 5, but then we're of course going to times that by the 6, the coefficient at the front. So root 25 is 5, times that by 6, give us 30, but we still got the root 3 there. Very similar on the next one. Root 4, we can square root. That's going to give us 2, but then we're timesing it by the 2 at the front to give us 4 again. And then we times that by the root 3 on the end. Final answer then. We notice they're now like terms. We can collect them together. I've got 30 root 3's, but I'm going to take away 4 root 3's. That means I'm going to have 26 of them altogether.